Hello and welcome. I'm your host, Allan Jude. Whether you're joining us live or watching this recording later, thank you for spending your time with us. For those of you who are new to Klara, we're a team of open source experts specializing in ZFS and FreeBSD, as well as Proxmox. We help companies worldwide optimize their systems, tackle complex technical challenges, and make the most of open source. So you should come talk to us if you're looking to build new or re-architect existing storage or virtualization environments, if you need support for or want to squeeze the most performance out of your ZFS or Proxmox, or if you want to develop new features and capabilities across your storage and virtualization stack. Before we dive in today, just a quick note, we are offering our ZFS storage design for Proxmox service. If you're building or re-architecting a Proxmox environment, we can help with some of the things we're talking about today. Whether that's for VDI, a regular virtualization cluster, or just general infrastructure, we can help with those workloads. But now, on to today's webinar, where we'll be talking about modern virtualized desktop infrastructure on Proxmox and about building high-performance desktops using open source infrastructure without being locked in with expensive vendor licenses. So please post your questions on Zoom as we go, and we'll be taking those throughout. And joining me today is Wendell Wilson, who I will have introduce himself here.
Hello, I'm an internet rando. I'm not just a Klara consultant, not even a consultant. I'm not just here at Klara's behest, but I've also hired Klara to do things, and so that has been awesome. Also, so Klara has been like fabulous and amazing. But we're here to talk about ZFS and all things ZFS, and I'm really enthusiastic ZFS, VDI and ZFS on VDI and like Proxmox and all the virtualization stuff. So I'm really excited about all that, and I think it's gonna be a lot of fun. I'm from Level One Tech, so you can check out Level One Techs, but basically I'm an internet rando.
I've been on Wendell's channel a few times too, and it's always a good time. When the two of us get together, lots of chat happens.
Listen, we just want to like, from my point of view, it's like I just want to fix stuff. There's broken stuff. There's a lot of unnecessary human suffering, and part of this presentation is telling you things you might not even know that you need to know, so that you have less suffering, and that's what it's all about.
Exactly. So one of the main things we're going to talk about is hyperconverged storage, which depends on your definition what that actually means. But the main thing we're talking about here is combining the storage in your hypervisor. So instead of having a bunch of compute nodes and separate from that some storage, it is putting the storage inside the hypervisor because that's going to give you the best latency. And so the reasons we do this, first one is comprehensibility. A system that you understand because it's just a computer with storage and CPU means it's a system you can fix when it breaks. If you have a very complicated cluster that needs, at least 7 nodes and quorum and uses all these fancy protocols, if something goes wrong, how do you fix it? Whereas if it's more straightforward storage like what you've used before, it is much easier to understand and therefore to fix.
Yeah, Alan asked him to add the star because I know some of you are coming from other hypervisors, and hyperconverged was a term that was sort of co-opted there to mean something else. And so we're talking about more of a simplified. We'll talk more about it in depth, but like it's like the VMware. It's like, oh, hyperconverged. VMware's definition of hyperconverged is a little left to center here.
Yeah. But one of the biggest advantages to dealing with the type of hyperconverged where the compute and the storage live in the same chassis is the latency. Any external storage is always going to take longer to access than something that's, directly connected to the motherboard that the CPU is in. When your limitation is basically PCIe bandwidth and latency, you can do a lot better than, if you have to go over a network and then through a consensus algorithm and so on before you can get those blocks read or written to storage.
Yeah, and the thing that a lot of people might not really into it is that because literally everything else except for server-to-server interconnects have, 10x and 100x and 1000x over the last 10 years. The storage, like it used to not be significant. It's like, oh, we're adding a little bit of extra latency, and it's like the spinning Rust storage latency is already astronomical if we have to travel across a fabric to get, to remote block storage. It's not really a lot. When we're talking about a single NVMe drive pushing 15 gigabytes per second read, any little bit of latency has a dramatic effect on throughput.
Yeah, with the hard drive, if you have that 4 or 5 millisecond average latency, then yeah, zero point 0.1 milliseconds from the network was just noise. But when you have an NVMe where you're talking, microseconds of latency, then suddenly every little bit on the network actually adds up to a lot,
Yeah.
and can effectively end up limiting your IOPS because it turns out IOPS are exactly inversely proportional to latency. If it takes longer to do a command, then you can't do as many commands per second.
And then you need more queues, and then it just turns into a mess.
Yeah, exactly. Another big factor is cost. Fewer systems and fewer components saves money. A simpler bill of materials and fewer different vendors to deal with is likely going to result in a much more cost-effective system. Uh, if
Yes.
you don't need 7 separate systems just to be able to have quorum in your cluster, you can just build an infrastructure with 2 systems. Then, that's a lot fewer systems. Even if it allows you to spend more money on those 2 systems to get 2 better systems, but at the same time, still getting that additional performance.
Yeah, this has also been really interesting to watch as it evolves in the enterprise because if you've been doing this long enough, some of the system architecture from 10 years ago, there was a lot of internal redundancy. There was even redundancy, like redundant paths to the drives, and that's making a little bit of a comeback with NVMe, where you got two PCIe Gen 5s to one lanes to one backplane, and two PCIe Gen 5 lanes to another backplane. But that's kind of exotic. Now we just sort of treat it as when the entire machine drops out, it's fine. The cluster will continue, and that is a more cost-effective system architecture. And so it's like we don't need 7 really expensive machines, but like 7 cheap machines would be as resilient. But also, you can get by with like 3 or 4, and because everything is fully replicated, it's you can have potato class machines, and the cluster will continue.
Well, and especially as we've seen the skyrocketing prices of RAM and NVMe, being able to put all the RAM you would have been able to afford in 7 systems into 3 or 4 systems might mean you actually get more value out of them because you don't have fragmentation where I have a little bit of free RAM, but it's spread across 7 machines, and I don't have any one machine with enough free RAM to run this next big VM. Whereas if I can concentrate the same amount of RAM in fewer machines, I will have that problem less frequently.
Yes. Yeah, it changes system architecture a little bit, but it's also you still get redundancy, but you're just sort of right sizing the redundancy instead of trying to hedge against every possible failure. It's like, oh, this failure was severe enough, we'll just eject the entire machine. It's not
Mhm.
worth trying to make the machine itself even more redundant.
Exactly. Obviously, hyperconverged means more throughput as well. But the biggest one that Wendell really wanted to harp on was repeatability. If we build a cookie cutter design that we can do over and over and over again, it's going to be much more effective than something more exotic that's hard to replicate.
Yes. Uh, I think also this is where one of the things where the hyper-converged people really get tripped up because it always descends into an argument of like, well, is it ZFS replication? Well, ZFS replication is not real time. You need something like Ceph, and it's like, okay, yes, that's true. But if you step back and think about the kind of replication that you actually need, you really just want right replication. Like when there's a change to your data set, how do you ensure that it replicates somewhere else? And so like a database server is a great example. Even with Ceph, if you lose a node, the node that the database server was running on will have to restart and you will lose whatever was in memory, whatever was uncommitted to disk. Now there's stuff in the database architecture, ACID compliance, sure, okay, and then Ceph agrees that this thing was written, and then like you have that, but you still have to boot up the virtual machine. Whereas most database systems, MariaDB, MySQL, you can do clustering at the database system level. So you have 3 VMs, let's say, in a 3 node cluster, and that is a better solution than Ceph even, because when you lose a machine, the database continues. The database does not actually go down at all in that high availability scenario, but you're not relying on the hypervisor's facilities for replication, or
Mhm.
the stacks facilities for replication, or for high availability. Either one, it's handled at the application layer.
Yeah, and the application has more visibility into what writes need to be persisted and we have to wait to do these and which ones we can let trail out and so on. And so doing it at the application level means that you can avoid the trade-offs that Ceph gives of like all your writes are going to be slower with Ceph because you have to wait for other nodes. Whereas if you're doing it at the application layer, at the storage layer, you can go with a faster solution like ZFS.
Yeah, I've even gone a little off script here. It's like it's turning into sin confession hour, but web servers. So like web servers is a popular use case, and I did a very large, very enterprise, very lots of web server front ends with a shared storage pool backend. But the storage demands of the backend were really not all that severe, and they wanted more throughput and more, and it actually made the most economic sense to just do ZFS replication, but not the traditional like 15 minutes. It's basically turned into a file system watch, and so we were doing a file system watch, but if it got to where it was doing a synchronization more than every 2 minutes, it would then batch them. So it's like if people were uploading a whole bunch of files across all of the web servers, then it was basically scripted synchronization. But that was a perfectly reasonable approach to the problem, thinking a little outside the box maybe. But ZFS, with the way that you can handle basically just like, let's replicate this data set over here. Okay, it's fanned out. Great. Uploads always go through this chain. Great. Handled. And then the throughput, there was no more, like if you graphed the throughput up to that point, it's like we're adding more machines, we're getting fall off in terms of adding the machine. And when we did that, it was linear. It's like, oh, we add another machine, we get this many more transactions. We add another machine, we get many more transactions. And so it's you got to understand what your problem is.
Yeah, where we had a case that was more the other way around. The content of the website doesn't really change much. It was all in the database. So we switched to each web server having its own local storage and using basically a git checkout of the website contents. And so they would just periodically pull that, but it meant that each web server can be completely independent and we could get rid of the shared storage that was usually the thing that was causing an outage rather than the thing that was protecting us in the event of one web server going out.
Yeah, that definitely falls under the comprehensibility thing. It's like I can
Yeah.
comprehend this. Like this scales from one server to 100 without, having this sort of black magic alchemy of what's going on in the storage. Coming from, like war stories from other hypervisors on every non-trivial installation I can think of where we had a support contract that cost more than 10 grand a year, there was always there was at least one or two incidents over the lifetime of those projects where something weird would happen. Like I'm thinking of one specific instance where I had to get tier one support to do some black magic to unlock something in VMFS because it was like, oh, this block that's associated with this VM is locked, and it's like it's locked by a phantom node. Like, what's going on? And it's like, oh yeah, we have to do something to actually force that to unlock, and it was not something that you could do without the vendor. And it was a very interesting support ticket because on the forum that we have, other people have echoed that. And I was like, that must happen more regularly than people let on.
Yeah, and what you don't want is a system with no user serviceable parts inside.
Yeah, yeah, yeah. It's back to the comprehensibility. It's like I don't comprehend what's happening with with the underlying block storage. I can see that this is obviously wrong. How do I work around this?
Exactly.
Oh yeah, the hypervisor is now part of the storage trust boundary. I love this. This is a great, very succinct way to say it.
Yeah, and so with this shift, when you're going with this hyperconverged, now because the storage is living with the hypervisor, you're getting to define where the trust boundaries are, and it gives you a lot of options. But if you're going to do this and use ZFS and Proxmox together, there are a few considerations you have to watch out for. And the first is deciding how to set up your VMs. And the biggest thing is you want to avoid having multiple levels of copy on write. So by default in KVM, the hypervisor that Proxmox uses, a lot of things are going to want to use QCOW2 disk images, which is great on regular file systems like your ext4, XFS, or whatever. But on top of ZFS, you're basically duplicating a bunch of the work, and you can cause up to 100,000 plus IOPS just to manage all the changes you're making. If you look at the kind of bottom left of this diagram, the guest makes a 4K write, and QCOW2 is like, okay, that actually has to be a 64K write because of the cluster size inside QCOW. And then we have to update all the level 2 table updates for that and all the ref counts. And all of those has to be written out to ZFS, which has its own different cluster size. And, if it's not configured, it'll be 128K. And so you're going to read, modify, write all of those updates you just did in the QCOW and make them twice as big again. So your 4K write turned into a bunch of 64K writes, which turned into a bunch of 128K writes. And suddenly you've massively expanded the amount of storage IO you're doing just to update 4K from a write from the VM.
Yes.
Whereas if you can get rid of the QCOW layer and just use raw images directly or using ZVOLs with ZFS, then your 4K write goes down to your ZVOL or to a ZFS file system that's been configured with a block size that makes sense. Then you will get basically no amplification, and you will get a lot better performance, and things will look a lot nicer.
I would
Uh,
also add that it is worth doing the ZVOL if you are using ZFS for a database storage volume, and also understanding the size, like setting the ZFS record size parameters and things like that to correspond with the database system that you are using.
Yeah, if it's MySQL or MariaDB, the page size is 16K. So lining that up so your ZVol uses 16K, or the record size on the data set that's going to hold the raw file has that same thing, that'll work better. And especially for database VMs, we'd actually recommend having two different backing disks. One that holds the operating system and all that, and a separate one that's just for the database data, and having that have that special cluster size, because in general, a record size in ZFS of 32K is probably going to give you the much better performance on the mix of big and small writes. And so for general use, we'd recommend 32K as the record size on ZFS. And then maybe having, like Wendell said, a dedicated ZVOL with the smaller block size just for the database part. And if you're using Postgres, the default page size is 8K. So you might need to tune it even differently. You also have to watch out with Proxmox, definitely in older versions, but I think even in 9.x, they still default to creating ZVOLs with an 8K block size. And the default in ZFS has changed to 16K because, especially if you're using RAID Z, the performance can be a lot better.
Yes, all of the things. Um, Also, I don't know if you know, mirrored volumes and striped mirrored volumes, you still do get the integrity
Hmm.
protection, and those are also absurdly fast. So you could create a totally separate mirrored to store for your database or for your ZVols or whatever, and like that's fine. Um, and then have RAID Z for like RAID Z in my experience has been fine for operating system drives and even at this point general use because the performance has improved so much, especially when backed by NVMe over the last couple of years, that for general purpose, like RAID Z is fine. I still see advice occasionally where it's like, no, you must only use, mirrors or striped mirrors or lots of vdevs of striped mirrors. And it's like, okay,
Hmm.
yes, that is absurdly fast, sure, but for general usage on Proxmox, RAID Z is basically fine.
Yeah, basically, uh, many mirror vdevs will give you more IOPS, but that only really matters when your drives don't have a lot of IOPS. So if you're doing all hard drives, it's really the only option to get any IOPS out of it. And if you're doing like SATA SSDs where you maybe only have 10 or 20,000 IOPS or something, then it can still make sense to go with mirrors. But yeah, if you have NVMe drives that do a million IOPS each, the RAID Z is going to be perfectly fine. And it's going to let you get more usable space out of it, and that can make the big difference. And to Wendell's point, you might also, if half your VMs are backups, like if you're using Veeam or something, then it might make sense to have a pool of RAID Z on hard drives to back up those because you're going to be doing all streaming rights to them. But then having your NVMe mirrored or RAID Z pool for doing, the IOP intensive workload that you might have.
Yes, and Veeam officially supports Proxmox At this point, woo!
Yep,
Although Proxmox Backup Server is pretty nice.
that too. So actually, you were going to talk about using ZFS replication with Proxmox.
Yes, yes, hyperconvergence. I can the chat is already on to me. Um, so this is in the GUI in Proxmox. It's like replication schedule every 15 minutes. This is basically fine. Um, and this lets you have local storage, and this is great because think about like the three node cluster. It's like if you have two nodes that are down, you no longer have a quorum. And so you can't move things, you can't change the configuration until you bring the quorum up unless you like get in there and hack CoreSync to make the one node that's up have more votes. Let's not talk about that. Um, but if you have Ceph or something like that, even a three node Ceph cluster, it's basically your only a real option with Ceph in a three node situation is to do um, full replication on all nodes so that you have, and so it's just, you end up with something that is a little more incomprehensible and perhaps only slightly more functional in the case of one node being down, but you don't really save any space and you don't really end up in a better position in terms of your space efficiency. But with hyperconvergence here, you can choose what your replication thing is to one or more nodes. So in a three node thing, you could replicate something to all three nodes for maximum redundancy. But you can also, you can also do replication to another node. And in my experience, this has worked fine and has held up really, really well. Um, and this is fine. But also a three node cluster with something like the MariaDB or MySQL is perfectly fine. It's perfectly reasonable.
Hmm.
High availability pfSense. So like you could use a virtualized router. And then it handles HA and the proxy ARP, CARP, all of that. And that's just two nodes. And again, you're not using the hypervisor's high availability. The high availability is handled at basically the application layer. That's all, and you have to do that a little bit with the database system. So like either your hosts that are connecting to the database have to be smart enough to choose another database server, or if you're doing containerized workloads, you can do like SQL proxy or HA proxy. On the level one text forum, there's a guide for setting up HA proxy with its SQL health check thing, and will automatically choose a database server that's up in one of three in a three node configuration. And all of those are way more sane ways to handle a three node, truly high availability thing that is doing VDI and database and like a web workload or whatever. But ZFS is extraordinarily redundant and resilient, even with crazy stuff like replicate this VM every 15 minutes. And so in a catastrophic failure, it's like you lose 15 minutes, like the last 15 minutes of whatever happened, which is not unreasonable IMHO. And closing the gap from 15 minutes to real time with something like Ceph, especially in a three node cluster, Ceph is not designed for three node stuff. I've got a video coming out where Ceph is not designed for consumer SSDs. I was using the P44 Pros, which turns out they have a firmware bug, and the Ceph
Oh, fun.
experience was catastrophically bad because Ceph is like, let me wait 30 seconds on this NVMe, and it's like, oh no. And so it was just like the whole cluster was haunted because there was a couple of P44 Pros that had hit the firmware bug, and the writes get squirrely when that happens. So
Yeah, and ZFS, you can go probably achieve even down to every 5 minutes with replication. But yeah, at that point, it really becomes a question of, okay, I can lose the last 5 minutes worth of stuff. Although if I did my database right and I'm replicating at the application layer, I have the logs and so on. So I'm not actually losing even that 5 minutes.
yeah.
Um,
The
but
database
I'm
server
not having
literally
to trade
doesn't
it.
go down. Like it doesn't
Yeah.
have to reboot it. Nothing. It's just it
Yep.
stays, and that is not true with Ceph and HA. Like you can't like it's like all right, you want to haul out the high availability replication. Let's talk replication. In this scenario, it doesn't go down, and you didn't need Ceph.
Yep. Exactly. There's a lot of trade-offs when you go from, local storage with ZFS to something more complicated like Ceph, where, every write's going to take longer, your latency is higher, and have all these extra, more complicated problems you can run into. Versus if you can, like you said, most applications actually support application level redundancy now because a lot of workloads are designed to work in the cloud as well, where it's like, all right, that whole region might go down and we'll just run it in the other region. And so treating your VM hosts almost rather than making them a cluster, treating them as separate shared nothing machines and doing the redundancy at the application level can give you a lot more value and a lot more security.
That's what I love about Proxmox is that even when it is in a clustered mode, you can still fall back to shared nothing in a truly catastrophic situation. At least with the ZFS storage backend.
Yep.
Oh yeah,
And you
this
always
thing.
have those backups.
Yes, and also like this is look how fast this is. This is NFS NFS over RDMA on Proxmox. It is not slow. That is 12 gigabytes per second. That is saturating the 100 gig Mellanox CX5 that was in the machine at 3% CPU utilization. Ah!
Yeah, you don't have to scale out to be fast. You can scale up. NVMe is awesome.
Yes.
Yeah, and we also talked about how you can do things like flex boot from iSCSI and so on to make these hosts much more replaceable, and just have everything be coming from a storage server that really gives you all the performance and capabilities you need without all the complexity.
Yes. And then what is the backing store on that NFS server? ZFS.
Yep. And so you know that your data is always going to be there no matter what happens.
Yes.
So getting to today's actual topic, modern VDI. Uh, the big thing that makes modern VDI different than kind of legacy VDI is the focus on perceptual parity. It should feel as fast and as good as working on a local machine. Basically, the people using VDI shouldn't feel like they're working on a laggy remote machine. They should feel like they can't tell the difference between you know, a machine they're sitting at and a VDI. Uh, so we're switching from, the old way of like remote desktop where you're trying to remote control a server at the end of a string to now a location independent workstation where I have the machine that would be at my desk wherever I am, letting me be a digital nomad or just work while traveling. And another big part of that can be disposable or pooled desktops, being able to uh, run everybody's machine and, make use of resources when people aren't online. Especially if you have people spread across a lot of time zones. They're not all necessarily going to need resources at the same time. It means you can actually get away with kind of over provisioning a little bit.
Yeah, this is the thing that I wish that Proxmox had more functionality for, but it is scriptable and through the API. And there's some forum posts and some hackery that I and some others on the forum have been working on. And this actually does work really well with SR-IOV, and Proxmox does give you the ability to pool the SR-IOV resources and assign them dynamically, which is nice.
Yeah. And you get a bunch of security benefits from this as well. You get control over, copy and paste, USB access, clipboard control policies, and so on, as well as integrated monitoring and logging, but also backups. If all the desktops for all the people at the company are on a bunch of Proxmox machines with ZFS, you can use ZFS replication and or Proxmox Backup Server, and you're now backing everything up. And there's no file that somebody forgot to save to the network drive and only exists on their desktop, and it's business critical. It's like, yeah, your whole desktop is also backed up. We're not letting the files get away from us anymore.
Yeah, this is also really critical in things like what is your ransomware recovery strategy, your ransomware recovery scenario, and with snapshots and CFS snapshots, which is different again. So like some refugees from other hypervisors will have a different idea of snapshots, and that the snapshots, it's like, oh, we have to use those with caution, and it's like, nah. There are ZFS volumes that I have on my home server where the files should not change. Like this is, like family photos or like something I'm archiving or whatever. And those snapshots exist all the way back to the beginning of time. It's like I have some rogue process that ran and is like, let me optimize your pictures for you. Thanks Windows or thanks OneDrive. Like OneDrive just decides to get, handsy with the local storage and starts doing stuff. Um, because the replications go back to the beginning of time, that is not a problem for ZFS architecture. I can have tens of thousands of snapshots. You shouldn't, but I can set a policy that's like, I'm going to keep all of the snapshots going back years, and I might have yearly snapshots for everything older than 5 years. And then over the next 5 years, it's like quarterly, and you get finer and finer granularity up till the present. And it's very easy to do that with ZFS, and very uh, reliable. Unlike hypervisor, it's like, let me create a snapshot of this, and it's like, oh, I have to merge this in later, and it's like, oh, I accidentally forgot about this. There's none of that.
Yeah, or even like LVM snapshots. As a counterexample to ZFS, every snapshot you take cuts the performance of the disks in half. And so if you get a couple too many snapshots, and suddenly you're getting like 30% of the performance that you should. Whereas because ZFS is copy on write and the way its snapshots are structured, you know, there's no difference in the latency of a read or write if you have 0 snapshots, 1 snapshot, 10 snapshots, or 10,000 snapshots. The only thing that gets slower when you have 10,000 snapshots is generating the list of snapshots. It's
That is
completely
very
out of
nice
band.
architecturally. Yeah.
Yes.
And yeah.
Yeah, and it can be a big part of cyber resilience, but also your recovery time objective. I was at my local community college where I used to teach a while back, and they were having a big outage. Some ransomware had gone wild over the network drive, and they're like, yeah, so we're having to restore from the offsite backup, and it's over a point-to-point link. And so, yeah, it's going to take us about 16 hours to try to get most of the stuff back. And we're going back to the night before's backup. I'm like,
Mm.
if you guys had ZFS, you'd run one command, you'd be back up within 10 minutes, uh, and you would have lost at most maybe 10 minutes of data, or you could go back to 10 minutes before the ransomware hit instead of a couple of days ago, the last time we're sure that there's nothing else in there. Because with ZFS snapshots, you can also examine the data and see how much has changed, what has changed, or what the files look like without having to restore them first. It really gives you a lot of additional capabilities.
Yeah, a lot of like under the hood, a lot of people don't understand that the ransomware that encrypts your files doesn't actually encrypt the whole file. It chooses specific blocks of the file and then encrypts those blocks. But with the way the ZFS works, it makes it extraordinarily easy to see, examine, and unwind those kinds of transactions. So it is laser scalpel focused on rolling back exactly what ransomware does.
Yeah, exactly. Like the one I encountered most recently did the first megabyte, the last megabyte, and the megabyte about a third of the way through the file. And that's all it encrypted. And so when it ran through all these, multi-terabyte VM images, it only took enough to make the VM not boot and not actually spending time rewriting terabytes and terabytes of data.
Yeah.
Let them get through all the files on the server a lot more quickly than if they just tried to encrypt everything.
Yep. And that makes it really easy to, it's like, oh, we don't have a local. And it's like, well, I mean, unless your remote link was just glacial, like transferring 3 MB over that remote link shouldn't be a big deal.
Exactly. But yeah, as you were saying, Proxmox is not a perfect drop-in replacement for something like VMware Horizon, but you can get pretty far with the tools that are available.
Yeah. Oh, guacamole. Yeah. Guacamole is amazing if you haven't seen, like, you should check out Apache Guacamole because you can string together what Guacamole does because you can log in with Guacamole and yeah, have LDAP integration and blah blah blah. But you could literally sit down with like Chat GPT or Anthropic, Claude, whatever, and string together something that uses the Proxmox API to take a gold master desktop and create an ephemeral disposable copy of that, or create one when somebody has a new account. So like you create an LDAP account, you sign into Guacamole, and then Guacamole in its machinery hits Proxmox and generates a desktop image from the gold image just for a person. Maintaining updates and things like that gets creative. You can choose a policy based on that. I would create a disposable ephemeral desktops where I have a gold master image, and every time somebody logs in, they get the image, but nothing is maintained on the image. Like it would mount the home directory from NFS, and things that the user would need would come from a shared storage pool, but the actual desktop is completely ephemeral, so that when I update the gold master, it will apply to everybody.
Yeah, next time you log in, you get the new VM. Exactly.
Yes. So, oh, we got a demo. Yeah, this is a lot of fun. This is Apache Guacamole, and so there's two VMs here that I've created. One without a GPU and one with a GPU VDI. And this is using Intel B50 For this video, Intel dropped the B60 SR-IOV firmware, and so that's in the firmware update manager. If you have a B60, you can now do 7 virtual functions. One GPU can host 7 GPU accelerated VDI things, and show is better than tell, so we can show you what the performance difference is with hardware accelerated VDIs. It's doing H.264 acceleration, but it's also doing video acceleration actually in the desktop, and it makes a much bigger difference on a modern desktop, even Linux, than you would expect. This is a Windows demo, but hardware accelerated desktop stuff makes the machine feel very snappy and feel like you're working local.
Yeah. So we'll get to Wendell's demo in just a sec. So what we're talking about here is why to get a good VDI experience, you need some GPU acceleration and how you can do that with Proxmox. And as Wendell was saying, these different GPUs where you can basically share one GPU to a bunch of different VMs to make sure that they're all getting this experience because VDI without GPU acceleration can be a very painful experience, which is I think, what this demo is going to demonstrate. So just before the video starts, we have this basic snapshot from it, and you can see on a machine with the GPU, as Wendell's moving around Google Earth and playing with things, the CPU usage is like 2%, and it's using some 20% of the GPU. When we did one without a GPU, it was using basically 100% of all, was it 6 or 8 cores you had?
6 cores, yeah, six
Yeah,
cores on the VM. It's like and you can't like if you were to create a 2-core VM, it is an awful experience for the end user because it's using all the CPU constantly for any kind of like window animation, dragging, and that kind of stuff. So unless you're only doing word processing, it's not an amazing experience.
indeed. So yeah, we got a video here.
Yeah,
Wendell can
we
talk
didn't
us
get
through it a little bit.
yeah, we
Yeah,
didn't get the audio. So like there's Guacamole, and it's like you just click on the thing in Guacamole, and it Guacamole can log you in and can do this. So this is you know, like it might not show in the video, but this is a pretty solid 30 FPS experience, and you can see as I'm dragging around and doing stuff there that there's GPU utilization in Task Manager, and then but the CPU utilization stays pretty consistently low, even though and the way this is rendered in the browser is, it is like a 3D application, and so if we switch to the other VM, notice there's no GPU there in Task Manager. This is like 12 FPS, and you can see the boxes there for the CPU. It's relying on the CPU to do everything. So if you had anything in the
yeah,
background that was running, it's the interactive stuff is competing with uh, the stuff that's running in the background because it's using most of the CPU to actually just draw stuff, which is not optimal. And you can't run. It's like, oh, let's run Heaven, and it's like with GPU acceleration, you can do it, but without GPU acceleration, you can't. So this is running, 30 FPS, 20 FPS, something like that. And it's on a B50, which is a $300 GPU. And this is 4 slices with 4 gigs each. So that GPU has 4 gigs of VRAM or 16 gigs of VRAM. And this instance on the B50 has 4 gigs of VRAM dedicated to it. So, which is kind of a lot. I mean, you could run dual 4K uh, remote VDI with this and still have a pretty good experience with 4 gigs of VRAM. Um, and that the B50 does 4 instances pretty well. Intel has been weird with the firmware on this though. Right now, the most current firmware on the B50 only allows 2 virtual functions. The version that I'm using here in the video allows up to 12 virtual functions, which is about 1 gig of VRAM per virtual function. The B60 is the 24 gig GPU. The firmware, they just dropped the firmware for that. So it's got 24 gigs of VRAM and it'll do up to 7 virtual functions. So you'll get even better performance with the B60 than the B50 that I'm showing here. The B50 is only a 75-watt card. It doesn't even require external power.
yeah. But it really goes to show what a difference the GPU can make, and just how you can manage those resources to have a lot of VMs running, and especially what happens when you don't. When we saw that CPU usage across all 6 cores using 100%, that also means there's none of that CPU capacity is available to other VMs. You don't expect most of your VMs to be running 100% GPU all the time. But if somebody just scrolling around Google Maps in a browser is using 100% of 6 cores, you're very quickly going to use up all the CPU you have. So
Yep.
having that one inexpensive GPU providing slices to a bunch of the VDIs at once means you're saving so much CPU that there's a lot more left over for all the actual work that these machines need to actually do, not just being able to scroll around in Google Maps without it lagging.
Now, up till now, this kind of thing has been basically locked behind a subscription. Like you'd have vGPU, and VMware has for a long time been a very first class experience with this kind of thing. But you would have to subscribe. There's a licensed subscription for that, and it ties in with Horizon and blah blah blah. But this thing from Intel is very exciting because Intel's putting their weight behind this kind of thing. This has actually been available in Red Hat OpenShift and or not OpenStack
Stack.
for one generation before this. Intel had their Flex GPUs, but weirdly, Intel partnered directly with Red Hat, and they didn't want to sell it to anybody else. But we did. There's some how-tos and stuff on the level one forum for getting the old Flex GPUs up and running on Proxmox as well. There's some driver stuff with this too, where it's like the pedigree of the Flex stuff sort of comes from like the i9-15, and the B50 and the B60 is from the Intel Xe graphics, and Intel Xe graphics is the future, and i9-15 is kind of like, I don't want to say it's on life support, but it kind of is on life support. Um, and so that has been interesting and slightly strange to watch. But Intel, there's no subscription here. These are SR-IOV virtual functions. And at the same time, Proxmox's plumbing for dealing with SR-IOV functions is fantastic. For the pfSense use case that I mentioned earlier, SR-IOV NICs pass through to a pfSense virtual machine, like full hardware network acceleration. Not, that also saves a ton of CPU overhead. And
Yeah,
Proxmox can
especially if
even
it's a network dedicated appliance, right?
yeah, exactly. And Proxmox also handles migrations with SR-IOV resources as well, because on each node you can be like, here's the SR-IOV virtual functions. This pool of SR-IOV devices, like this SR-IOV device is like this one, is like this one, is like this one. And so Proxmox can manage, okay, I can move this VM from here to here because the other physical host has an available SR-IOV resource. It knows.
Yeah, so we have pass through where we give an entire device to one particular VM. So that's often used for storage controllers into people that wanted to run TrueNAS as a VM or something. Network devices, I have a whole network card I want to give to my pfSense or a whole GPU. But SR-IOV is a technology where those hardware meant for that use case can basically split itself up and show up as a bunch of what are called virtual functions. And you can basically take one 100 gig NIC and give virtual versions of it to 8 different VMs, and all the traffic will go out to your network, and it'll all work how it's supposed to, but with one card that you're actually hardware passing through to each VM. So all those network heavy workloads have direct access to, they're running the same driver as if it was the host instead of, using VirtIO net or something that's going to try to paravirtualize and lower the overhead, but still not going to be as good as directly having access to the hardware.
Yeah, SR-IOV also enables you to do fun things like RDMA, even where the host drivers don't necessarily allow, like the plumbing is not all there in for RDMA. You can still use RDMA in a guest. There's
Mhm.
one really sort of famous-ish situation that I'm surprised. Well, Red Hat has a really amazing set of patches that are not mainline kernel for dealing with RDMA in these contexts, and that does not exist in the Proxmox kernel. But you can still pass through an SR-IOV device to a virtualized, Rocky Linux or Red Hat Enterprise, and then get the full RDMA acceleration in that scenario, even if the host doesn't necessarily have it, or maybe the host doesn't need it. It depends on what you're doing.
Yep. And then there's a couple other technologies we can talk a little bit about, although we're running short on time. So CXL in the future might actually allow you to do disaggregation and borrow memory and GPU from the other hypervisor machines in your cluster to kind of solve that problem we talked about of I have a bit of free RAM on every machine and not enough on any one machine. And then AI workloads, right? When we're doing this SRIOV or the MIG and other things we'll talk about in just a second, being able to use any slack time you have on these GPUs for your AI workloads as well.
Yeah, if you need to tokenize a bunch of documents for retrieval augmented generation, spin down your VDI desktops and spin up an image and attach the SR-IOV resources from the B50, B60, or MIG that we'll talk about in a second. Easy to do.
Exactly. And so, at night when nobody's on their desktop, you can be making use of those cards in the meantime.
I will also mention that multi-instance GPU MIG, so like an RTX Pro 6000, supports hard partitioning. This is different than vGPU. So you can run an RTX Pro 6000 in four 24 gig slices. It has 96 gigs of VRAM. You can do smaller vGPU slices, but you're back to the licensing thing, and it's also arbitrary. There's three versions of the RTX Pro 6000. Only the server version is officially supported for vGPU. But if you just throw an RTX Pro 6000 in there and you enable MIG, that's supported on all three of them, you can get four slices that are hardware independent. It is hardware partitioning, and that is nice from a security standpoint as well.
Yeah, you don't have to worry about side channel attacks and so on because they're completely hardware separate. They're not, shared resources.
Yeah, and we've already covered Intel SR-IOV, the B50, and now the B60. B60 was not on the slide because SR-IOV firmware had not dropped. It's in Firmware Update Manager now, 7 virtual functions it works, and it's less flaky than the B50. Woo!
Yeah, yeah, and we just talked about live migration and pass through and how that works. But
Yeah.
you have a great demo here
Oh
as
yeah,
well.
this is what the UI looks like. Is like you just, it's like, okay, these are my functions. This is where it's going to go, and create a PCIe mapping. And I've named it XE SRIOV devices, but it knows like the same mapping on different nodes is how Proxmox knows that it can migrate a VM from one to the other. And there's the live migration capable experimental checkbox that is very experimental. I would not recommend that for production, live migration for production with SRIOV graphics, but it's not completely failed in my testing.
Yep. So one last thing we want to talk about, big advantage of using ZFS is getting access to some of the ZFS features, like the new fast dedupe. So data duplication basically turns your data growth from a cost problem into an efficiency advantage by eliminating that repetition at scale. Especially if you're doing this VDI thing like Wendell was talking about, where we're spinning up new copies of the same VM every time someone logs in, there's going to be a lot of duplicate blocks we can take advantage of there. Possibly even more if you're doing it long term without the ephemeral VMs, where you're not re-cloning off the golden image as frequently. So ZFS deduplication has long been discouraged because of the performance problems, but starting with Proxmox 9, it includes a newer version of ZFS 2.3 that includes the fast dedupe feature that Klara developed for TrueNAS, and it basically provides a bunch of enhancements and lessens all of those penalties. So it increases performance and even gives you the option of offline dedupe now with the rewrite command. So a future version of Proxmox that incorporates ZFS 2.4 will have even more capability. But with fast dedupe, you get dedupe quota, so that you can limit how much RAM dedupe is going to take, so that you can make sure you're saving enough RAM for the VMs on your hypervisor. You can have a dedicated dedupe vdev, so you can, even if your storage is hard drive based for backup, you can have the dedupe table live on an NVMe to get the speed you need. And then dedupe prune to ensure that you can, when you do hit that quota of the amount of RAM you want to spend on dedupe, you can decide to purge old entries to make room for new ones and get the most out of everything. But in order for dedupe to work properly, you need to have data alignment. So that means, when the same file in two different VMs needs to start on a sector boundary, not somewhere in the middle. And so that means when you're doing your physical to virtual conversion or just using QCalConvert to convert an existing image, when you're converting it to RAW, as we recommended at the beginning of this video, you want to make sure that everything lines up on the ZFS record size or vol block size boundary. So that means tuning the file system inside the VM and the VM image itself to make all that stuff line up. As we talked about, if you don't, you can end up causing a lot more I/O than you need, but also if the file starts at different offsets, dedupe's not going to see it as the same, and you're not going to get all the advantages. So yeah, you want to map the file system cluster size, the image cluster size, and the ZFS block size from top to bottom, and then you'll be able to get the most out of things. So the criteria to consider on whether you want to use dedupe or not, the biggest thing is, do you have enough repeated data to be worth it? Is your data actually going to be aligned on the ZFS block boundaries so that you will actually find the duplicates? Do you have suitable hardware? You need RAM for this fast dedupe translation table. If you're already constrained on RAM and barely have enough RAM for the VMs you want to run, maybe it's not a good fit. But if you can make sure you have a little bit of extra RAM to store this table, it means you could save a lot of storage. And that might mean the difference between being able to afford those, NVMe that can do 7 GB a second versus having to stick with, SATA SSDs that are only going to do 500 megabytes a second each. And, that can make a big difference in your deployment. We worked with a video game developer who's running their CI system, and basically on the cost, if they could keep their 8-to-1 dedupe ratio, they can afford for it to be all NVMe and be fast. If they can't keep that dedupe ratio, they could only afford enough capacity if they bought, 8 times as many hard drives as they had NVMe, and then the performance was never going to be good. So tweaking it to make it work for them was really important. But the biggest gotcha is encryption. If the VM's using whole disk encryption or the application is encrypting data, if you have two VMs, even with the same application, they're going to have different random keys and they're going to encrypt the data differently, and suddenly it's not a duplicate anymore. That one has bitten quite a few people, especially with Windows starting to default to BitLocker now. But also, if the application does some kind of compression, if you're using a database like MySQL or whatever, some of them now try to do native compression themselves, like using LZ4 or something. And if they do that, it changes how the data gets laid out and makes it not line up. And it doesn't always compress the same every time, and that means it's not going to deduplicate.
Yeah, the deduplication or the Windows 11 BitLocker thing has already caused some problems for some of the users in our community. In that it's like all the dedupe stuff was great, and then our storage just exploded, and it turns out all of the VDI VMs were quietly on their own using their virtual TPM module to do encryption, and so everything was slowly not deduping, slowly eating the thing, and so they had to deploy a group policy to roll that back, and they're still recovering.
Yeah. So if you're interested in getting a Proxmox setup like what we described today, check out the link at the QR code, and we'd love to hear from you and help you design a new Proxmox-based infrastructure. So we got a question here from David, who asks, it's interesting information about a GPU. Do I have to have two GPUs in order to do this? And the answer is no. With the SR-IOV, when you configure it, there'll be the main instance, and then you'll get a bunch of virtual functions that you can give to the VMs. So it's not going to necessarily take the GPU away from the Proxmox console itself.
Yeah.
Also, depending on your server board, you might actually already have an embedded GPU for like the out of band management, like the IPMI. So there might already be a second GPU that you can use and then be able to have the whole GPU for VMs. But that only really matters if you're doing full pass-through where you're giving the entire GPU to one VM for a very specialized workload. But with the MIG or the SR-IOV, you will still have an instance that you can use for the host.
Well, MIG is interesting because when you enable multi-instance GPU, the physical outputs on the card stop working entirely.
That's a good point. So if you depend on plugging a monitor into your Proxmox thing, that's maybe changes things a little bit.
Now the B50, it did work, but also the B50. So like the B50's been in beta. Like I get, the level one community basically has been beta testing this B50 thing for a while. And an early version of B50 that had 12 virtual functions, you could still use the desktop interactively, and it was fine if that was your only GPU, which I thought was surprising because that's usually not how that works. Some of the old, like the Fire Pro AMD GPUs, which also had SR-IOV, had like one display connector that was like you had to take off the mounting bracket and you could like kind of use it for debugging. But then when you got everything working, it also disabled the output. So, but most server boards have built-in VGA or some kind of built-in display. So it's in practice, it's usually not an issue. Even if you're doing like an AM5, like I'm building my home lab server or the fancy new AM5 Epics from AMD, they have built-in video in the CPU, so that counts as one, and then you can add your SR-IOV GPU and get your 7 or 12 virtual functions or whatever, and it's fine.
All right. I think we're at time. Thank you so much, Wendell. We had a great time.
No problem. I don't care to stick around and keep answering questions if you want. I mean,
Yeah, yeah, you can maybe get one or two more in here. Uh, Michael asks, how many active desktops could you stream with the setup, and what kind of network bandwidth or latency would be sensible?
so if you did the B60 with 7 virtual functions, each desktop is only because it's like H.264. You might be able to do H.265 at this point or like AV1, but H.264, you're on the order of like 6 megabit per stream peak. Real world's usually way less than that. Um, so supporting 7 VDI desktops per GPU at under 100 megabit is easy.
Another person asks, can you repeat how many slices you get with the B50 versus the B60?
So in right now with the B50 with the very latest firmware on the firmware update manager, you get 2. Historically, you get 12. There's a guide on the forum to get the version of the firmware for the B50 that gives you 12 virtual functions. There's a catch though. When you're using more than 2 virtual functions, it is a little more squirrely about the VMs. The driver version matters, and it's important that every VM have the same version of the Intel driver. It seems like when they were doing 12 virtual functions, they were maybe a little optimistic because there seems to be under the hood a little bit of a cooperative aspect to it, whereas the 2 virtual functions have been a lot more stable in the modern version. I've got questions to Intel as to because I was told that the B50 was going to have 4 virtual functions and maybe more, and the B60 they weren't sure about, but it was going to be more. And so where we are now is like the B60 firmware seems to be the not beta firmware, and it seems to be more solid. You get 7 virtual functions on the B60, but the B50, the latest version of the firmware, is only 2 virtual functions, and that was in the change log from Intel, but Intel has not officially told me. Is like, yeah, we changed our mind from 4 to 2, which would be super disappointing if that's the case. But you can also still roll back to the version that does 12, and if you're willing to deal with some of the caveats, you can have 12 virtual functions on the B50, which is about a gigabyte per function.
Yep. So Thomas asks about ZFS dedupe. If you have a dedupe vdev and it goes belly up, do you lose your duplicate files? No, the dedupe vdev only stores the dedupe table, which is the list of all the SHA-256s of the files and how many copies there are and where those copies are. It's mostly used when deleting files to know if it's the last copy of the data to be able to free it. So it's bad, and it would probably mean you would never get any space back when you deleted a file because ZFS could never be sure. So we definitely recommend that being a redundant drive, at least a mirror or something. But that is likely much more recoverable than losing any other whole VDEV in ZFS other than, an L2 arc. Um, so you'd want to design to have redundancy on all the VDEVs you have in ZFS. But the dedupe one is fairly critical, but not as critical as like a metadata VDEV, where if you lose that, you don't know where any of the blocks on the system are, and that's very catastrophic. But for dedupe, it is a bit more recoverable than losing most other types of VDEV, but it likely, if you've lost that data, you be able to read your data, but you probably wouldn't want to try to write much more to it because you really aren't able to free any data because you're not able to say, all right, this is definitely the last copy of that block and I'm okay to free it now. So kind
Yay!
of interesting related question here. If you have a PCIe, M.2 adapter card, so a PCIe card where you're putting a bunch of these M2s on it, is it a good idea to create your pool across separate adapters in case one fails, or is there likely to be more of a performance hit from doing that? Specifically thinking of the metadata special VDEV.
Uh,
Ah,
I've
mhm.
I've done that a lot. I've never experienced a card failure. Um, it doesn't make a difference performance wise unless it's a problem like because of your CPU. Like you can have chipset lanes in a desktop scenario, but like generally, as long as all the slots are all lanes back to the CPU, there should not be a performance implication. Motherboard design sometimes means that like the lower slots on the bottom of the motherboard are a better choice for adapter cards that don't have any repeaters or redrivers for signal integrity reasons versus the ones that are closer to the CPU generally don't have redrivers or retimers, and so like that could be a little more problematic for one of those adapters for signal integrity, especially like PCIe Gen 5 speeds. So counterintuitively, the slots farther from the CPU have better signal integrity because there's more extra stuff on the motherboard to deal with that. But from like the ZFS side of it, you can speak to that, I think.
Yeah, I think in general, counterintuitively, it would actually be the other way. Spreading it across the cards is more likely to be slightly faster just because you're not, you have separate lanes that way and you're not saturating one set of lanes completely as much as using both. Uh, but yeah, in
Well, no, those
general, it is fine and there's no
those
reason to worry about it.
those cards are all passive. So
Mhm.
the 16 lanes becomes four groups of four. It is exactly the same PCIe bandwidth from one card that has four to the other ones, unless you're
Mhm.
doing like a Broadcom adapter. And so, like, then yes, I agree with you. If it's like the Broadcom adapter where it's like 16 Gen 4 lanes into 32 Gen 4 lanes for SAS, SATA, or
Right.
NVMe, and then yes, spreading it across those would be good. But for the passive ones, it's literally just a physical adapter. It doesn't change the lanes. 16 into 4 by 4 is a software setting on the CPU.
So one more question. What layer are you using for a backup pool for ZFS? So while I might use, mirrors on the primary, on the backup, usually it's RAID Z2 or RAID Z3, depending on the requirement and just exactly how many disks I have. Because you're, replicating the data over and you're mostly going to be receiving all the writes in big linear batches. And the same, even when you're trying to restore, you're going to be reading it back in the same way. And so that extra space efficiency and getting that much more backup just means I can keep more backups or a longer trail of snapshots by having that more uh, space efficient backup. Whereas I might optimize for IOPS and performance more on the primary host.
It's also true that Proxmox Backup Server uses some of the underlying magic of ZFS to actually let you start the VM from the backup storage. So, like in a catastrophic scenario, it can be restoring using the magic of ZFS, but you're actually running off of an instance. The VM, the storage is actually just on Proxmox Backup Server. It actually doesn't do a storage migration. It just runs from over there over the network with some perhaps negative performance implications, but that is like I don't care that it's slow. It needs to be back up. It's like okay, click.
That's one of the great things about ZFS replication is on the received side, it is the whole file system, right? You have the whole ZVOL or the whole, raw backing file. And so yeah, you can just boot the VM directly on the backup server, or you can expose it over NFS and boot it on some other server that you stood up temporarily or whatever you need to do. Your backup is not in an archive or on a tape somewhere where you can only restore it. You can actually use it live from that copy.
Yep. Which is like it's magic. I mean, you pay a lot of money extra in other scenarios to get the functionality there that is there basically out of the box.
Yep. And last question, does Klara offer or work with any partners to provide a full Proxmox / VDI solution, including hardware and ongoing support? So yeah, Klara, uh, with our design solution, we can help you find the best hardware partner in your location, and basically design out the system or even review the hardware quote you have from your favorite vendor if you already have somebody you prefer to work with just because you have a relationship or whatever. We can help you with all that and get the system up and running and integrated. And using our support subscription, have support for the ZFS and the Proxmox parts of that through the whole life cycle. All right. Thanks, everyone. And we'll see you
Thanks.
next
Thanks for
time.
tuning in or watching the video on demand. Hit us up if you got questions.
Yep. There we go.
Yay.
Yay.
Good, you think?
Yep. I didn't think we were going to be quite so tight on time. We had lots to say.
Sorry.
No, it's good. And we started a few minutes late, so it made sense to go.
It's all good.
We had good stuff too, right? So, like,
Yeah.
I don't think we wasted any of the time we had. So,
Yeah. And people seemed like they were genuinely